All right. We're going to talk about asymptotes and intercepts. Intercepts are the previous section, really. Asymptotes are the previous video. So really, this whole video, you've already done it, okay? Don't believe me? Well, let's check it out. Remember, right, if I have a logarithm, log graphs kind of look like this, where the domain of something like this would be 0 to infinity. And the asymptote is x equals 0. Well, I don't care if I move things over. What if I shift the graph over to the right? We get something very, very similar, right? The domain is now going to be, I don't know, maybe it's 2 to infinity. And the asymptote comes right along with it. Right, now the asymptote is a vertical line, x is equal to 2. So your domain and your asymptote are really, really closely related. Even if I reflected it, right? Even if I reflected it the other way, sorry, really hard to see a video preview right now. I have a cat that's licking herself in front of my monitor. Even if I like reflect it and move it over and maybe we get something like that, the domain here would be negative infinity to negative 2 or whatever. But again, the asymptote just comes along with the domain. The asymptote would be x is equal to negative 2. So if you can find the domain, asymptote, it's no problem. Okay? So example 3, 2, 1. Blast off. All right. Find the domain and vertical asymptote. This is a really nice question. Because again, if we do one, we've already got the other. Well, if we do domain, we already have asymptote. Not always perfectly the other way. Y is equal to the natural log of 3 minus x. And remember, for the domain, I don't care what kind of logarithm it is. Log base 2, log base 17, log base pi, log base 77. For the domain, the only thing that matters is that the inside is positive. Okay, so for the domain, we need 3 minus x to be positive. Subtract 3 from both sides, multiply by a negative 1, inequality switches, and you can get x has to be less than 3. Okay, so our domain is all the numbers that are less than 3. As soon as we have that domain, I know the asymptote. Asymptote will always be a vertical line for a logarithm, and it's going to be that number that's in the domain. Okay, domain, we already found that in the previous video. Asymptote just comes along with it. Remember, it's a line. The line x equals 3 is all of the numbers have an x value of 3. So it's that vertical line right there. Okay. Let's do another one of these. Harpy. All right. F of x is equal to 3 log of negative x plus 2. Remember, if there's no subscript, there's an implied subscript of 10. This is the common log, right? Just like this is the cubed root, but if we don't write an index, we just assume 2. Okay. So again, for domain, I don't care about all the stuff on the outside. I don't care what base it is. For domain, I only care about the inside. We're tunnel visioning, okay? We just need the inside to be positive. The inside here is negative x. Divide both sides by a negative 1. You're going to get x has to be less than 0. 0 divided by negative 1 is still 0. Our domain is all the numbers that are less than 0. And our asymptote, I wish there was a good abbreviation for this. I can think of a good abbreviation, but it's not really appropriate to write down. So asymptote comes along with the domain. It'll be x equals 0. All right. And that's the first half of this video. And the only other thing kind of involves a little earlier stuff. You know how to do this. You just might not remember. Okay. Example 3, refreshen time. Find the domain, the range, and the intercepts. We already know how to find the domain and range. And I claim that you already know how to find the intercepts as well. Just have to refresh. So part A, f of x is equal to the common log, log base 10, of 5x plus 10 plus 3. All right. Let's just do things one at a time. Oh, range. I already know it. The range of any logarithm, negative infinity to positive infinity. Whew. All right, I got a little excited there. Domain is going to be a little bit more complicated. Asymptote will be x equals whatever the number in the domain is. We don't need to find the asymptote here. Whatever. I'm telling you the asymptote anyway. All right. No, we need the intercepts. We'll look at x-intercept and y-intercept. And that'll be our answer. I'm boxing things ahead of time today. Okay. For the domain, the inside has to be positive. So we need 5x plus 10 to be positive. Subtract 10. Divide by 5. X is greater than negative 2. All the numbers bigger than negative 2 look like that. And again, that immediately tells us our asymptote. For the x-intercept and the y-intercept, you just have to remember what intercepts are. The x-intercept, right, is where it crosses the x-axis, which has a y value of 0 right here. So we say, okay, x-intercept, that's when y is equal to 0. Y-intercept, that's when x is equal to 0. So you just plug in y equals 0, that's going to be 0, equals the common log of 5x plus 10 plus 3. And you say, yeah, how do I solve this? Well, this is the book giving you a little opportunity to excel, okay? Because the book hasn't talked about this, and the book's not going to talk about this for 2 more sections. The idea is we want to convert it into exponential form. So let's move that 3 over. Negative 3 is equal to the common log of 5x plus 10. And remember, if there's no subscript, it's like a subscript of 10. Now we convert this to exponential form, and we can finish solving after that. Okay? So the base of the logarithm is the base of our exponential. The input of the logarithm becomes our output. And our output over here becomes the input of the exponential. That was the previous video. And you can definitely solve this equation. Just subtract 10 from both sides and divide by 5. So 10 to the negative 3, that's 0.001. 5x plus 10. So we're going to subtract 10 from both sides. Oh dear, we're going to get negative 9.999. And divide by 5. Okay, all right, I'm lost. I had not doing that in my head. But it should be like negative 1.19. I don't know. Let's write that out. Negative 9.999 divided by 5 should be negative 1.9998. All right. And we can check our answers. Type it into your calculator. When x is equal to that, what does your y value become? The common log of 5 times negative 1.9998 plus 10, and then add 3 equals 0. Okay, you type that into your calculator, you're going to get 0. So we know that's indeed our x-intercept. Negative 1.9998. The y-intercept is much easier. Okay, y-intercept is when x is equal to 0. So y is going to be the common log of 5 times 0 plus 10 plus 3. All right, that's the common log. 5 times 0 is just 0 of 10 plus 3. This is 10 raised to what power equals 10? Oh, these are inverse functions. They cancel each other out. We just left with the exponent, which is like a hidden 1. So our y-intercept's a little nicer. It's just 4. And that's how you do these problems. So really, it's the x-intercept that's going to get you. Because honestly, we haven't really talked about this. But now we have. So let's do part B, and then we'll be good to go. The guy is really starting to terrify me. All right, part B is find domain, range, and intercepts for f of x is equal to log base 2 of x plus 2 minus 5. So we need to find the domain, we need to find the range, we need to find the x-intercept, the y-intercept. And if you want to talk about the asymptote, go for it. And I'm boxing my answer. Range. I already know the range. The domain of any exponential function is the same as the range of its inverse, the logarithm. Domain of an exponential is going to be all real numbers, so the range of a logarithm is also going to be all real numbers. Okay, domain takes a little bit more work. For the domain, we need the inside to be positive. Subtract 2, x is going to be bigger than -2. So if we were asked the asymptote, that'd be x equals -2. We were not asked the asymptote, but that's what it would be, that vertical line. And you could graph this function and talk about it. All right. X-intercept's a little harder. X-intercept is when y equals 0. The y-intercept is when x is 0. So when is 0 equal to log base 2 of x plus 2 minus 5? Add 5 to both sides so we can get the logarithm by itself. And now we're going to put this in exponential form. Base of the logarithm becomes the base of the exponential. The input becomes the output, and the output becomes the input. Well, 2 to the 5th power is 32. I can solve this equation, so can you. That kind of rhymed, a little catchy. We'll make a song about this problem. Song about 6.4, example 3b. Subtract 2 and we're done. X is 30. That's our x-intercept. Y-intercept's a little easier. You just plug in 0 for x. So our y-intercept is going to be log base 2 of 0 plus 2 minus 5. And we simplify that. Log base 2 of 2. These are inverse functions. 2 is the same as 2 to the 1st power. They cancel each other out. We're just left with that exponent, which is 1. Y-intercept is -4. Let's say hypothetically you're not super confident in your mathing ability. You can check your answer for all of these. Let's look at the most recent one we did, okay? I'm going to blind you for a little bit. Then we're going to reverse contrast mode. Let's type in that function. Y is equal to log base 2. Use a subscript. I'm typing the underscore character right here to get log base 2 of x plus 2 minus 5. Let's look at this function and see if we're correct. One thing at a time. We said the domain is -2 to infinity. The x values, the x values get really close to -2. X values get really close to -2. And the x values get as big as they want. So domain looks right. We said the range was all real numbers. Yep, y, look at the y coordinate. It can get as negative as we want. And the y coordinate can also get as big as we want. All right. The x-intercept we said was at 30. Are we right? Let's scroll over. Oh, x-intercept's at 30. The y-intercept we said was at -4. Perfect. Good. All right, so we can visualize this logarithm this way as well. All right, and I think that's it for this video. Yeah, it is. If you have questions, you let me know.